Alright, this lesson is intended to serve as your introduction to constructions. And we've done constructions at the beginning of this course just a little bit, but we're going to get more heavily into what they're used for, how they're used, the proper technique for them. So this lesson is supposed to be the overview of it. So as you can see at the top of this page, construction is defined to be the creation of a geometric object, which is a line, a segment, angle, or polygon of some sort, following the simple rules in the box on page 1. A straight edge may be used only to draw segments, so you may not measure with a straight edge. We use rulers as straight edges, but not for the centimeters or inch markings. A compass can be used to draw a circle or arc of a known center and known radius, and no other tools besides the writing utensil can be used. So what ends up happening is the compass gets set at a point and radius established, and then because every radius you draw with that compass is the same, it ends up creating equal distances, and we end up using the compass as a measuring tool. Alright, so starting with the construction of an equilateral triangle that we have witnessed before. Hopefully this is a bit of a review for you. Given segment AB, shown below, do the following, and this one's already complete, as several of these will be. But what you're seeing here, you have line segment AB. We're supposed to draw a circle whose center is at A and whose radius is equal to length of AB. So what you need to do is set your compass from point A to point B, metal point on A, pencil point on B, and then draw this arc that you see here going through point B. That's with a compass centered at A. And then we want to flip the compass over, keeping the radius the same. Put your metal point on B and make a second arc. And that second arc should intersect your first arc above the line at a distance that's equal from both of them. So we should have point C at that intersection. Alright, so once we have that point marked, we can create segments AC and AB, and we have our equilateral triangle. So you don't need to make the full circles. If you did, that's fine, but we try to want to save markings. If you want to just make the partial arcs, that's good. But the reason why this must be equilateral, and you can pause the video at any point now to copy this down, but both of these arcs have a radius that's equal to segment AB, and that's because we set the compass to be that. So the intersection of those two arcs has to be the same distance away from each point. So if AC equals AB, because the compass said so, and BC equals AB because the compass said so, you would have all three sides of equal length, so an equilateral triangle. And so as I mentioned just a minute ago, the compass is actually used to measure more than it is for anything else. Alright, so exercise 2, given the diagram of the circle below, circle shown whose center is at R, points S and T on the circle, why must it be isosceles? Well, it's marked isosceles, but the reason we're able to mark that isosceles is because every circle has an infinite number of equal radii. So any two of those radii have to be the same length. So in this case, both RS and RT are drawn as radii of the same circle. And so by definition, we have an isosceles triangle. Okay, on to page 2. Using only your compass and straight edge, we can create a variety of triangles. So this is actually an important point for this unit. Whenever you do a construction, make sure you leave your markings, because it'll be impossible to tell what your procedure was if we have erasures. So try to keep all of your markings on the page. So we're trying to construct an isosceles triangle using segment MN, so that's already provided for you, whose legs are congruent to AB. So not only do we want an isosceles triangle, but we want one that has those leg lengths of AB. So the first thing you want to do is set your compass to the length of the leg that you want. So I would put my compass point on B and the pencil on A. There's a marking at A here. That's not really necessary. You just need your compass to be that size. So then what we do is we take that compass setting, put the metal point on one of your endpoints. This one I think was done with M first. And you make an arc from M. So this arc here that I'm pointing to in the diagram. That arc is formed by a compass point at M with segment length AB. And then we flip the compass over to N and do the same thing. So it's similar to the equilateral triangle construction, except we're not using segment MN this time, we're using some other arbitrary length. So what the takeaway here is, you can make it any length you want and create an isosceles triangle. And then the way you make it a more specific equilateral triangle is to make that compass length the side that you start with. But it'll always be at least isosceles with this procedure. Okay, so then last thing here is to remind you how to make congruent triangles. So given triangle ABC, construct RST such that RST is congruent to ABC. So point R is our starting point, and we would basically want to start by making sure we have a ray, right? We always want a ray that's long enough to accommodate the segment length that we're trying to copy. So ray RS would be longer than what you need. We take our compass point and put it on A, and we measure off one of the segments. So if we want to keep it in the same orientation, maybe we want to measure AB first and reproduce RS so that the naming matches up. So if I put my compass point on A and my pencil point on B, and then just lift the compass and carry it over to my point R, then I can intersect the new base on the ray to find point S. So RS is, because of the compass, the same length as AB. Once I've done that, then what I want to do is go back to my original triangle and figure out what the length of either AC or AB is. Okay, so then I think what the directions are saying here, to draw an arc from S with radius BC, it doesn't matter which one you do next. Okay, you've got your base segment copied. You can either do AC next or BC next. If you do AC, then you need to make sure you come from R, because again, from the naming, R and A correspond. And if you do BC next, you have to come from S, so that those correspond. But otherwise, it doesn't matter which order you do them in. So what you're seeing here is these two arcs in space were then joined with segments. So just to recap that, if I put my metal point at A and my pencil point at C, this arc here is not necessary, I just have to measure it. But what I want to do then is lift the compass over to point R and make another arc that has that same distance, so don't change the compass size. I don't know yet where T is though with only one arc, so I have to go back to my original triangle, put my metal point on B, and my pencil point on C so that it's wider, and I'm copying segment BC. Then the metal point goes on S, and I can figure out where that arc will intersect to make point T. And the reasons for all of this, I know that RS is equal to AB, and RT is equal to AC, and ST is equal to BC because I did them by construction. So that reason by construction is essentially saying that the two segments are equal because we constructed them to be that way. So we can use that reason anytime we're using a compass to guarantee side lengths. So that will come up occasionally in this unit. And then finally, the triangles are congruent because of SSS. We don't need the word theorem there if you don't want it, but it's because we created three equal sides in both triangles. So that's your beginning introduction to Unit 4. And we will continue with increasing levels of difficulty with constructions in this unit.